Using a number line, Part 1. Lesson objectives: graph and compare numbers on a number line. Compare numbers using inequality symbols. Let's begin. So why do we want to use a number line in statistics? Well, a number line is a nice way of visualizing the numbers and how they relate to one another. So that will allow us to compare numbers. A number line can help us visualize what's called the center and spread of a data set. We will use z-scores in this class, and that is the distance away from the mean. And again, that can be visualized using a number line. What's called the point estimate and margin of error in confidence intervals can be visualized using a number line. And lastly, in quantitative graphs such as dot plots, histograms, and box plots, a number line can be used. So here is a number line. The more you are to the left, the smaller the numbers. The more you are to the right, the larger the numbers. So clearly 9 is bigger than 5, which is bigger than 2, which is bigger than -1. And we can say -9 is more to the left than -5, therefore -9 is smaller. Let's graph the location of these numbers on a number line. So our first step is we want to convert everything to decimals. So here we have a fraction 4/9. So if we take 4 and divide it by 9, we get 0.4 repeating. Next is 3/4. -3/4 becomes a -0.75. That's a decimal. This is the absolute value of -9. Absolute value is always positive. We can think of that as like distance. So this quantity here becomes the positive number 9. And then we have a -6.3. So graphing each of these, we begin with 4/9, which is 0.4 repeating. So 0.4 repeating is a little bit less than half on the positive end. So that would be about here. Next is -3, that's to the left. So that's smaller. Next is -0.75, -3/4. Okay, here's -1, here's 0. -3/4 is in between these two. So if this is a half, 3/4 would be about here. Okay, next is a +3. That is the largest number thus far. Then we have 6.9. So here's 6. It's closer to 7, almost 7. We'll put it here. Next is the absolute value of -9, which is a +9. That's our biggest number. And then finally we have a -6.3. So here's -6. It's in between -6 and -7. It's closer to -6. And that should be about here. So as we can see, -6.3 is the smallest number in this data set. The largest number is +9. Let's do another example. Graph the following on the number line. All numbers between and equal to 2 and 7. So this is what we call an interval of numbers. It's all numbers including 2 all the way up to 7 including 7. So we go to the smallest number, that would be 2, and we want all numbers from 2 and including 7. So this is an interval of numbers, and we color this in to indicate to the reader that any number here in red is between 2 and 7. Now later on when we talk about confidence intervals, a confidence interval is an interval that will be a lot like this in between two numbers, an upper limit and a lower limit. And it can be any value in between those upper and lower limits. Let's compare numbers using inequality symbols. So let's review an inequality symbol. And I like to think of inequality symbols using Pac-Man. So here we have a comparison of two numbers, 5 and 7. Now, if we graph this on the number line, clearly 5 is smaller than 7. Another way we can say that is 7 is larger than 5. But one of these statements, both these are mathematical statements, one of these statements is incorrect and one of them is correct. So if we think about the inequality symbol as being part of Pac-Man, and the first one we are saying that Pac-Man is going to eat the 7, that 7 is the bigger number. On the bottom we are saying that Pac-Man is going to eat the 5, therefore 5 is the larger number. So clearly the first statement is correct and the second one is incorrect. The inequality symbol can be thought of as like Pac-Man's mouth. It is always going to eat the larger number. Let's look at some more symbols. So this symbol means a less than. So as we read it from left to right, just like we would a sentence, this would be read as less than. So some examples would be 2 is less than 5 and -6 is less than -1. So if we put these on the number line, 2 would be to the left of 5, -6 would be to the left of -1. These are true statements. The next symbol is a less than or equal to. In statistics, there's not really that much of a difference between the two. Mathematically, less than or equal to means that it can be less than, but it can also be equal to. Some examples would be 4 is less than or equal to 7. That is correct. 4 is less than 7, so that's a true statement. -3 is less than or equal to 0. That's a true statement. And then the last one, 8 is a less than or equal to 8. Now 8 is not less than 8, but 8 is equal to 8. So this is a true statement. Next we have greater than. So if we read this symbol from left to right, we would say this is the greater than symbol. So examples would be 9 is greater than 2 and -4 is greater than -6. If we thought of this on the number line, 9 is more to the right than 2 and -4 is more to the right than -6. And then last we have the greater than or equal to symbol, and this works the same way as before. 8 is greater than or equal to 3. That's true. -2 is greater than or equal to -8. And then the last one, 10 is greater than or equal to 10. That's a true statement. Let's try some examples. True or false? 5 is less than 7. Well, that is true. Is 4 greater than 0? That's true also. Is 2 greater than or equal to 2? Well, 2 is equal to 2, so that's true. 12 less than or equal to 3? Well, that is false. 12 is larger. 50 is less than a 99. Pac-Man is eating the 99. That's larger. That is true. 1 is greater than 1.5. That is false. 1.5 is greater than 1. 1.2 is less than 1.3. That is true. On a number line, 1.3 is more to the right than 1.2. 0.3 is less than 0.25. So if we think of this as money, 0.3 is like 30 cents. This only has one decimal place. This has two decimal places, so we can always put a 0 to the right of the decimal point. So this is 0.30, 30. This is 0.25. 0.30 is larger than 0.25. Pac-Man is eating the 0.25, so this is false. This is a false statement. And then the last one, 0.05 is greater than 0.8. Again, if we think of this as money, this is a nickel compared to 80 cents, 8 dimes. So this is false. Let's try some more. -5 is less than -7. If we put this on the number line, -7 is more to the left than -5. So this is false. -5 is larger than -7. 6 is greater than -8. That is correct. -2 is greater than or equal to 2. Well, that is false. Negative 2 is less than positive 2. Negative 3 is greater than or equal to a negative 3.01. So which number is more to the right? Well, that would be negative 3. And since negative 3 is more to the right than negative 3.01, it is larger. This symbol is stating that it is larger. This is a true statement. 0.05 is a less than 0.049. Okay, if we think about this as being 3 digits, this needs to have 3 digits. So if we add a 0, so this would become 0.050 compared to 0.049. So this is the larger number, but the inequality symbol is saying this is the larger number. So this is false. Negative 9.02 is less than negative 9.2. Again, this has more decimal places, so we need to add a 0 to this one. So negative 9.20 is more to the left than negative 9.02. This number is closer to negative 9. This number is more to the right. Therefore, this is a false statement. 1/5 is less than 1/8. Whenever dealing with fractions, we want to change them to decimals, so grab your calculator. 1 divided by 5 is 0.2. 1 divided by 8 is 0.125. On the number line, 0.2 is more to the right than 0.125, so this is false. The Pac-Man is eating the wrong number. 1/5 is greater than 1/8. Next we have 2/5 and 0.25. 2 divided by 5 is 0.4. So 0.4 is the same thing as 0.40. That is greater than 0.25. So this is true. And the last one, 3/4 as a decimal is 0.75. Is 0.75 greater than 0.8? Again, 2 decimal places. If we add a 0, this is 0.80, this is 0.75. 0.75 is less than. This is saying greater than, so this is false. Thanks for watching.